All right, good morning, welcome back. Happy Friday. Today we are covering class number 9, which is in context linear problems. In context we can translate to word problems. Coming up next week, a little bit unusual, on Monday we have our one and only catch-up day during the semester. Just a moment to catch our breaths and make sure that we are solid on all the material we've seen so far. I have no agenda. I'm not going to come up here and present this problem or that problem. It's essentially just going to be, hey, go work on problems that are difficult for you and raise a flag and I'll walk around. So it'll look just like the group activities, but I have nothing specific that I'm going to come in and say on that day. But please do come in. Don't think of it as a day off. Come in and see it as a day to work on stuff that is challenging for you while you have me and you have your classmates around you to help. Then on Wednesday coming up, we have quest number 2. The material covered is lessons 6 through 9. That is everything that wasn't covered on the first quest. So 6, 7, 8, and then what we do today. It is not too early to start studying for quest number 2. It's coming up on Wednesday. And a very, very good source of problems for that quest and for all of our quests and tests is that practice problems packet, which is completely optional, but if you never look at it, you're missing an opportunity. So I'd encourage you to start studying over the weekend for this quest, and in particular take advantage of those problems because all those problems have videos of me solving them on YouTube. So if you get stuck, you have a resource no matter what time of day it is. Okay, questions? All right, then let's jump in here on page 68 for lesson 9. In this lesson, we use real-world data to find equations of lines, and then we'll use our equations to solve problems. The nice thing about today is that technically there's really nothing new. We're going to do word problems. We're going to translate those word problems into a pair of points. That's a big step. Once it's a pair of points, then it's an ordinary find the equation of the line, which we've done 1,000 times already. And then we'll answer some questions about the specific context, right? But really nothing new. Okay, number 1, we are going to use our calculators on this one. According to a report in USA Today, sales for personal breathalyzers have spiked in recent years. The CEO of Wintergreen Research reported that the 2009 personal breathalyzer market was valued at $215 million, up from $28 million in 2005. We will assume that sales are growing at a constant rate and use these figures to predict the value of the personal breathalyzer market in 2015. So let's give this a shot. We're going to define 2 variables and figure out which is independent and which is dependent, and of course we will include units. So just looking at this data, it says 2009, the market was valued at $215 million. So our 2 variables are going to be the time, that's the 2009, and then the value of the market, that's the 215 million. But one of these is clearly the independent variable. Is it clear to you guys? Which one is the independent one? Is the years. If time is involved in a problem, guaranteed it is the independent variable. Time marches on. Time could care less about the breathalyzer market, but as a result of time passing, things change, including the value of this market. So independent variable is time, but do not just say time. Tell me the units. Time in years. Now I'm going to add to that in just a second, but in its current form, we can start writing our ordered pair. What is the first variable for the highlighted stuff? I said the independent was the time in years, so which of those 2 numbers? 2009 goes right here. Don't write this. 2009 goes right there. Totally fine. This means that the calculations we do are going to involve the number 2009, which is a pretty darn big number. And so it is in our best interest to avoid some of the complications of dealing with the number 2000 by just reshuffling, changing it so it's not just time in years, but time in years since some more recent number. Since when? 2005 is fine. 2005, I think Oliver is picking it because that was the other year that was given, right? Since 2005. Another choice? Time since 2000. That's a really natural one because then it's really easy to figure out what the adjusted value is. I'm going to do 2000 here. If I'm being honest, Oliver's choice of 2005 makes our work easier, and I'm trying to make our work a little bit harder here just in case the problem is not one where the work is easier. But if we go with Oliver's idea, using 2005 as the start of the experiment, then that the 28 million in 2005, that's the y-intercept, and it's just given to you because Oliver has chosen so wisely, hey, I'm just going to start the experiment in 2005, and bam, we have the y-intercept. But I want to make sure that we know how to find the y-intercept even if it's not given to you. So we're going to do time since 2000, which means that the highlighted information, what's the input variable now, or the input value? It is just plain 9, right? Time since 2000. And dealing with 9 is just going to lead to smaller numbers than dealing with 2009. It's just a choice. There are lots of acceptable choices here. This will be the one we'll make. Okay, dependent variable, that must be the other thing. That's the value of the market. So we'll just say value of the market in, and we got to make sure we include units. Dollars is good. Another choice? Millions of dollars. Oh, billion, million, millions, right? Both choices are totally fine. If you choose dollars, then what number are you obligated to put here in this second spot? Don't put this. But if you just say dollars, you are forced to write that and do all of your calculations with that. I would again prefer to do my calculations with smaller numbers. And so if instead of dollars we say millions of dollars, then what does the second value become now? Just 215. And I don't know about you, but I would much rather deal with those numbers than the numbers we had before. 2009, 215 million with all 6 zeros. Okay, so our highlighted stuff up above has become that point. Can you guys go ahead and write the other points based on the other information in the problem? Okay, what's the input? 5, right? Because we did years since 2000. What's the output? It's just plain 28. Some people think they need to take the 28 and subtract it from the 215 or add it to the 215 because it says up from. If it had said up 28 million, then we'd have some arithmetic to do. But it doesn't say up 28 million, it says up from 28 million. So it's just plain 28 there. No calculations to do. Any questions on translating the stuff in the paragraph into those 2 points? Once it's translated, the rest of this is a fairly routine problem. Find the equation of the line. We've done it lots of times before. Let's do it now. So part C, write the equation of the line that contains these 2 points. Hint, begin by finding the slope. For sure, we have to find the slope at the start of every one of these equation of a line problems. So upstairs, what minus what? Downstairs, somebody else? Good, and we got to make sure we do it in the same order, which we did. Okay, what do we get here? 13, is that 187 on top? 187 over 4. You're welcome to leave it as a fraction. I often go to decimals when I'm in word problems, so can somebody give me the decimal here? Great. 46.75, that's the slope. And now that we've got the slope, we're ready to write down the some formula for the equation of a line. You could either do the y minus y1 version or the mx plus b. I think most of us are preferring mx plus b, so that's what I'll do here. That 46.75, where does it go? That's the m, so we're just going to make that one small change. I'm not sure if I've said this before, but I'm going to say it repeatedly during the semester. A lot of math is about copying everything except making one small change. And folks oftentimes run into trouble when they do too many things in one step, like to try to do 2 steps in one line. I just think that's not a good idea. So all I did was make one small change and I copied everything else. Now we're going to make another small change and we're going to copy everything else. At this point, we're going to plug in the X and the Y from one of our highlighted points. It makes no difference which one you pick. If I have choices, I pick smaller numbers over bigger numbers, so I'm going to plug in the green. So instead of Y, we're going to use what number? 28 equals 4675 is copied. Instead of X, we use what number? 5 plus, and then the B is copied. Again, make one small change and copy everything else. We changed the X and Y and we copied everything else. 28 equals, all right, somebody help me out here. 230, what? Thank you. Plus the B. And solve for B by subtracting that 233.75. What do we get? 205.75. Do I have that right? Yes. Okay, and then we write our final equation, which is copied from over here. Y equals 46.75x plus the B, which we just found is a negative 205.75. Okay, so that's our equation. Any questions on the calculations? It's the same process, doesn't matter where the points came from. Let's find the slope, let's plug into mx plus b and follow the bouncing ball. So don't be intimidated by the words. It's a familiar process. As soon as we had those highlighted points, it was routine. Okay, and now we'll come back to the context of the problem and answer 2 questions. Part D, interpret the meaning of the slope in this context. Write a sentence in plain English. First of all, if your sentence does not include the number that is the slope, you are losing points. What number needs to be in our sentence? 46.75 has to be in there. People sometimes talk very abstractly in this interpret the slope sentence, but I want specifics. I want this concrete use of the number 46.75. Okay, so for me to understand the slope, I need units. That's how I always start with the slope. So going back to the 215 minus the 28, what were the units on those numbers? Millions of dollars, millions. 9 and the 5 came from 2009 and 2005. Those were years. So what that means is that the units of this 46.75 are that fraction that we just wrote there. It's millions of dollars. I don't quite know how to write that per year, right? And I very subtly just used the word per instead of that divided by, but that gives me a way to understand what that number represents. $46.75 million per year. Perfect, that's our sentence. Just tying it back into the problem itself. Okay, Jeff, one more time for everybody. Jeff, one more time with the sentence. You don't need to say the starting from. All I'm looking for is this is an interpret the slope. The only number I need in there is the slope. 46. Right, I don't need the y-intercept. Okay, that's a full credit sentence. Doesn't have to be exactly those words. There are other full credit sentences, but they generally look like that. How did Jeff know this was an increase and not a decrease? It was a positive 46.75, right? If it were negative, that would mean a decrease. That's it. Okay, and then finally, part E, predict the value of personal breathalyzers that will be sold in 2015 and interpret your solution by writing a complete sentence. So 2015, that's a value of X, that's an input, but we're not going to plug 2015 in. What number are we plugging in? 15, because we chose to start the clock in the year 2000. Okay, so y equals, what did we have? I'm just going to copy our equation. 46.75x minus, what was it? 228? 205.75. Thank you. So just copying our equation, but now we're changing the x to 15. That's it. And then we have to do a little bit of arithmetic. Anybody have this number for us? Great. And in terms of a sentence, our sentence just needs to include two pieces of information and then a couple of words to pad it. One of the numbers, so one of the pieces of information is that 495.5. What's the other? It's the 2015. Some people talk about the slope. They talk about the 46.75. Some people want to include the y-intercept in here, but really this is a problem with a single input and a single output. In 2015, the breathalyzer market was worth $495.5 million. That's the full sentence. Okay. Just give me the input and the output. So I'm not going to write the sentence, but it is written out someplace here at the bottom of the next page. We predict in 2015, the personal breathalyzer market will have a value of $495.5 million. Okay, so activities start on the next page. All three of these problems are calculator active problems, but do a lot of writing before you start typing things into the calculator. I'll walk around and help.